So we recently learned about expressions, and we say that an expression contains various terms. The first one, we always begin with defining a variable such as x square and y, correct? And then we also define a constant. A constant is a number in an expression that stays the same irrespective of whatever value the variable takes, correct? And then we say that we have coefficients. Those coefficients are the numbers that are in direct multiplication with variables, such as 5, that is a coefficient of x square. 4 is a coefficient of variable y, correct? So given this knowledge, now let us take a look at some of these expressions here, and we will define how many terms each expression has, and based on the number of the terms, we will define what kind of expression that is. So my very first example is expression containing 5z. Even though there are two different things here, there is a constant and then there is a variable, but they are in multiplication with each other, right? Hence, I will say that this contains only one term, and such expressions are called monomials. All right, all expressions containing one term are called monomials. Then the example number 2, it has two terms. Term 1 is 6x square, right? And the second term is a constant. And yes, you guessed it right. Every constant in an expression is also a term. So this expression contains two terms. I'll write here, and such expressions are called binomials. All right. Then we have an expression that contains three terms. 5x square is 1, 4y is second term, and negative 2, that is third term. So this has three terms, and such expressions are called trinomials. All right. And then you can say that, well, the fourth expression, the fourth example, it has 1, 2, 3, 4. It has four terms, and hence it will be called a polynomial. But at the same time, I will also say that all of these expressions, whether monomials or binomials or trinomials, they can also be defined as the polynomials. Only thing is that for such polynomials that contains 1, 2, or 3 terms, we have defined a unique name for such expressions. Okay. All right. So it is time to learn about another concept, and that is about what are like and unlike terms in an expression. Okay. So we define like terms as the terms that contain either the same variable or if they contain the constants, right? So given that understanding, I'll say that in expression 3, I see that there is a term containing 4y, and then there is a term containing 3y in expression number 4. So I will say 4y and 3y are like terms only because they contain the same variable. The variable is y. It doesn't matter what is their coefficient, because coefficient do not matter. They only define how many units of that variable we have, right? So that is why we say that 4y and 3y, they are like terms. What other like term I see is that the constant presence in expression 3 and the constant in expression 4. They are also like terms, and I will list them under here. Okay, then I will say, let's compare the 5x square. I do see that it has name x in the variable, but it has a power of 2. And there is x in expression 4, but it has a power of 3. So I will say 5x square and 4x cube. They are unlike terms only because the power of these variables is different, and that makes them a unique variable. Okay, x square is not the same thing as x cube. Okay, hence they are unlike variables or unlike terms. Okay, likewise, you will say that I can find many more combinations, something like 5x square and 4z square. They are also unlike terms because they contain entirely different variables, right? So this is how you will make a distinction of like and unlike variables. And the importance of these things you will find when we are learning about the addition or subtraction operations, because only like terms can be added or subtracted together. Okay, with that, we will take a pause here. Our objective was basically to learn about what are expressions, various types of expressions, what are their unique names, and how do you count the number of terms in an expression. And accordingly, we also learned about a distinction of like and unlike terms. All right, with that, let us take a pause here, and in our next tutorial, we'll go learn about performing some mathematical operations.